Welcome to another episode of the MSDN Show. In this episode, we're going to focus on one of the facets of Windows DNA, that being COM+. COM+ is what provides the services that applications can take advantage of to just work that much better on the Windows platform. But before we get into that, I want to let you know that we do indeed read the comments you guys leave on our webpage. And I've noticed some of the comments have to deal with the interface that you're watching the show on. Now, for those people out there that are using Internet Explorer 4 or 5 to watch the show, you're getting our dynamic HTML viewer that we specifically designed for viewing the show with. Now, if you look carefully, right down there is a button that says Show Transcript. When you click on that button, over here, yeah, go ahead and click on it. Okay. Over here will come a transcript window that shows you all of the text that my guests are speaking in this show. Now, if you'll notice, as the show progresses, there'll be a colored box that walks down the transcript to show you what is currently being said. This allows you to easily scroll up and scroll down the transcript window and find out exactly where we're at. Or you can click on the Sync Transcript button up there to jump directly to the place where the transcript currently is showing. Now, if you look closely, you'll also see a little camera next to some of the transcript text. Yeah, right there. If you click on one of those, don't click on it yet, but if you click on one of those cameras, that will actually jump this show to that section of the transcript where you're watching. So if you're watching the show and you need to stop for some reason, just remember where in the transcript you were when you had to stop. Then when you come back, start the show up again, open the transcript window, scroll to that location, then click on the camera, and there you are. Now, sit back, don't click on the cameras yet, and watch the rest of the show.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. Last month, MSDN Online launched a new portal for accessing the hundreds of code samples in the MSDN library and other sites. The MSDN Code Center provides quick and easy access to code samples and sample applications. Developers can browse the colorized source code online before downloading the files. They can also rate and comment on the code. More than 100 code samples are available today, with more being added every week. Check out the MSDN Code Center at msdn.microsoft.com/code. In the second half of this year, Microsoft will make available a version of Windows 2000 for computers using Intel's new 64-bit Itanium processor. The existing SDK for Windows 2000 already includes the tools, documentation, and resource files necessary to allow application developers to create both 32-bit and 64-bit applications from the same sources. 64-bit Windows 2000 and applications built for it can take advantage of the advanced scalability, large 64-bit integer and memory support, and extensive multiprocessing that Itanium-based systems will provide. If you want to know more about 64-bit Windows, check out the information on our public website. The transcript will have the full URL. The March 2000 Microsoft XML Parser Technology Preview is now available on MSDN. This release, an update to the January 2000 Technology Preview, provides improved XSLT XPath standard compliance, including support for name templates and the HTML output method and complete XPath support. In addition, a number of bugs from the January release have been fixed. For more information, visit msdn.microsoft.com/xml. TechEd is Microsoft's annual technical training event targeted at corporate developers and consultants. This year's event will be held June 5th through June 8th in Orlando, Florida, and will focus on Windows DNA 2000. Attendees will learn how to design, deploy, and maintain solutions that utilize the latest in enterprise and web technologies. In addition to the U.S. event in June, TechEd will also be in several additional locations worldwide. For more information about TechEd, as well as its worldwide schedule, please check out msdn.microsoft.com/events/TechEd. And that's been the MSDN News Update. I'm Erica Wiechers.
One of the key aspects of Windows DNA is COM+. It provides the infrastructure that applications utilize to access services and capabilities beyond the scope of the developers that are actually building those applications. In today's episode of the MSDN show, we're going to take and try to cover what COM Plus is, how it relates to the applications you're developing, and hopefully you'll better understand how to utilize these services. To help us understand COM Plus, I've got with me Paul Flessner, Vice President of SQL Server and Middleware, and Joe Long, who's a Group Manager of COM Plus. Paul, real briefly, how do you see COM Plus as fitting in with the overall scope of Microsoft technologies?
COM Plus is one of the core runtimes that enables an application execution environment that really allows developers to transact those applications, make them secure, and provides a hosting environment that's both highly performant and very easy to manage for crisp and professional execution of applications.
Now, a lot of that description sounds very similar to what people are talking about with their web applications and e-commerce and that sort of stuff. Is COM Plus designed just to deal with the web application and e-commerce solutions?
It certainly is very good in that environment, and that was certainly a design point, but no, it'll work just fine on an intranet application or a traditional kind of classic two-tier application.
Mm-hmm. Now, Joe, when I hear COM Plus, the first thing that came into my mind, the very first time I heard it, I think, okay, COM is the programming model we use for developing component object model applications. COM Plus is just the next version of that. But that's not quite the case. What exactly is COM Plus?
So COM Plus is an evolution of technology, the very COM that you're talking about, as well as MTS, Microsoft Transaction Server, that we came out with, I think in 1995 was our first version. And Microsoft Transaction Server introduced for the first time attribute-based programming, where you could build your application, and then after you've built it, you can essentially check a checkbox to say what kind of services you want for the application, whether it's security or transactions or synchronization. And what COM Plus is the next iteration of the MTS technologies combined with the COM and DCOM stuff. So think of COM Plus as a combination of COM, DCOM, and MTS combined together into one product.
So it's leveraging the COM programming model to enable additional services to be added to an application transparently?
Correct. It's exactly the COM programming model. In fact, my team is the COM team as well as the MTS team. And so it really, we call it COM Plus. We could have easily have called it, the next iteration of COM or OA, or MTS 3.0. We just chose COM Plus to kind of give you the sense of it's just COM but more.
So what I'm taking from that is that services that applications normally might have had to develop themselves in order to provide functionality, COM Plus is now providing those services that a COM-based application can easily just connect up to and utilize.
Sure, but let's actually talk about what an application is to kind of scope where all these things fit in. So the application that we're targeting, there's actually two types. One type is a typical inside firewall intranet application where you might have a thick client or a browser, and there's also the application where you're outside the firewall and you have a browser client. But in any case, you have your client which connects to your server either through a firewall or not through a firewall. And then on the server, you're running a web server, in this case IIS, and you typically have an ASP script that runs and creates COM Plus objects that in the back end access SQL Server.
No, the ASP script creates COM Plus objects?
Well, the ASP script typically creates COM Plus objects, though we have pretty good integration with IIS where you can actually mark an ASP script as transacted, and there you're actually running inside the COM Plus infrastructure. In fact, if you use an ASP page, you're using COM Plus because on a technical sense, every single ASP page runs inside of a COM Plus activity which provides synchronization semantics and on a COM Plus thread. So if you want to look at the total number of customers that COM Plus has, count all the ASP customers as well. So this is the typical three-tier application that you read about, where the client is the web browser. The server, typically inside a firewall, is IIS running COM Plus, and the third tier is the back-end SQL Server. What the COM Plus environment provides you is a lot of the services that you would need to build highly scalable, highly performant, reliable applications.
That's a lot of buzzwords and stuff like that. What does that mean exactly?
We'll try and get into that. I think that when people try to build applications, there's a certain sets of functionalities they must have in order to build scalable applications. And that Intel does a lot of the functionality by building the hardware, and then the NT group goes and builds an operating system, provides a lot of functionality. In the past, developers would have to go through and build a lot of their own functionality. They have to build their own thread pools for scalability. They'd have to build their own object pools, their own data access layers, their own security model. And these things are services that we're providing with Com Plus. And the idea is to allow relatively simple programming models so that our typical customers might be a Visual Basic or a Java developer. And they get to write their application as if they're the only entity in the world that's writing it. They can treat them as single-threaded components. They don't have to worry about any of the threading issues. And then what they do is they register them in our environment, and we provide all of the multi-threading that you would need to be a scalable application. We provide, you can just do a checkbox and you get transacted. And we deal with all the transaction semantics for doing distributed transactions between one or more SQL servers.
Now, when you say clicking a checkbox, that reminds me of like with MFC or something like that, where I've got a wizard that's building the application for me, and I click that checkbox, and then code is then spewed into my source code base. Is that the same thing's going on here?
Not exactly, although there is tool support inside of ATL for saying you want to be a transaction server component, and there is tool support inside of Visual Basic that allows you to say what kind of transaction you want. And with our next generation tools, the support gets better and better along the way. But what I talk about checkbox, the idea is that you understand the semantics that you want in your application when you build it, but then you compile it into a DLL, into a COM object, the same COM that you've known and loved all these years, and then you just register it in a tool that we write. And when you register in the tool, you get to have a whole set of services, and you get to pick which ones apply to this particular object. Those services are transactions for doing two-phase commit across multiple resource managers. Security, and we have this role-based security that we can talk about more if you'd like, and a host of other ones, queuing and events and other kinds of services that you might need to build your application.
So in essence, rather than actually embedding code that performs this functionality into your application source code, you're basically just subscribing to services that are part of the Com Plus environment running on the operating system.
Correct. It's, as much as possible, we tried to make it so that there was seamless integration between the applications that you're running and then the services provided by the environment, so that we try to be as unobtrusive as possible as you go through and build your code.
Yeah, it sounds like Com Plus is creating a additional evolution of services on the platform. You talked about MTS being the very first one it came out with, and as things are moving forward, we're constantly enhancing that and adding to it and building more functionality into Windows because of that. Paul, maybe you can address moving forward with Com Plus. Is that the direction we're going with the object model in the future, or is Com Plus this little island over here that's just going to be providing security and queuing and events and so forth?
That's certainly not an island. We are providing a complete set of services to build great scalable, highly reliable internet intranet applications. Services. Com Plus provides an important set of services. There are also services that provide application hosting and execution, message queuing, data access, and then, of course, storage on the back end. And Com Plus plays an integral part of that in terms of kind of an execution environment for those objects. It provides a lot of important services, both for performance and security and a host of others. And Com Plus will continue to play an important role in our architecture going forward.
So it's a good thing for people to bet on today of actually starting to get involved in Com and Com Plus programming so they can take advantage of some of these capabilities.
Absolutely, yes.
From an application standpoint, I mean, just talking about all these different services available and so forth, that doesn't really explain the architecture that an application developer that wants to address Com Plus needs to think about in their application. I'm assuming that this whole model requires a slightly different mindset in the same way that a DOS programmer, when they first wanted to write a Windows application, there's a whole big infrastructure architecture of Windows that they need to understand in order to make their DOS application properly work in the Windows environment. Is the true for Com Plus?
Yes, it is true. There's the fundamental idea behind Com Plus is that we want to be a platform that enables you to build scalable applications, and that we assume a lot of that burden in building a lot of the infrastructure that you would need to be scalable for thread pools and so on. But there's still some requirements that we can't do for developers, the developer to do. I would say the most important one is to build stateless applications.
And by stateless, what do you mean exactly?
What stateless means is that when you write your component, that between method calls, and it can actually be between multiple method calls, but at some point the component needs to give up its state to allow the resources that it's holding. When you hold on to state, you're typically holding on to resources, whether it's a database connection or memory or anything else that the application needs. You need to give that up so that that resources can be shared by other components. In our execution environment, we have potentially hundreds, if not thousands, of components running at the same time. And if you are holding state in these components, all the other components that need that state are competing for it. And what this causes is a bottleneck for throughput, and you end up not being scalable.
Now, for a programmer, holding state essentially means maintaining variables with specific values across execution boundaries.
Correct.
As well as maybe like opening up a database resource and leaving it open on one call, so the next time you're called in, you don't have to go through the whole opening process to grab that resource again.
Right. Let me give you an example. In the typical MTS and COM+ programming model, a method call comes in. The first thing you do is acquire the state necessary to do your work. This might be go and get a database connection, for example. And then you do your work, and then you give the state back. And in the COM+ programming model, we have this API we called set complete, which basically says two things. It says I am ready to commit the transaction if a transaction exists, and it says deactivate me when you return. From a client perspective, they just hold on to a reference and make calls over and over again, but the server object is controlling its own lifetime via this set complete method. And when I go set complete, the actual instance of the object is destroyed and goes away. And so the object acquired the state necessary to do the work. Now, in a stateful environment, what you might do is actually already have the state you need to do your work, and you just access it from a memory variable. You then do the work, and then you return that state so that somebody else can take advantage of it. And all of this is controlled with server-side lifetime via the set complete. And if you decide that you want to abort the transaction for some reason, you call the set abort method.
Yeah, but it sounds to me like, as a programmer, that if every single time one of my functions is being called, I've got to recreate my environment, then do the thing you asked me to do, and then destroy my environment, that seems like a lot of wasted time. I mean,
right.
Does it work out that way? Or
intuitively, you might think that you waste a lot of time because you want to do caching, but you have to understand this environment. There are so many objects running. You can imagine, let's take stretch it out. Let's say there's 1 million objects trying to access the one little piece of state that you have, and each of those 1 million objects has to use it in turn. Well, you really only ever have one object running at a time, because the first object has the state and is doing the work, and the second object is waiting for the first object to be done. And so you have to transfer that along these 1 million objects. They all wait for it to be used. We also provide facilities that help you doing the state management. First of all, my big belief is that state really you should put state where it belongs, which is in the database. We have lots of examples of customers that come to me that are building their own in-memory databases or building their own in-memory caches to try to facilitate acquiring state quicker. And we found in virtually every single case, in fact, there's not an exception that I know of, that the best thing to do is put the state in SQL Server. And if you want it to be in memory, just give SQL Server more memory, and SQL Server becomes your in-memory cache.
What exactly, you're using SQL Server as maintaining your state?
Correct.
Is that like storing the variables as a record set inside a SQL Server, or is it more than that?
That's a fine way to do it. Typically, the kind of state that they need is everything from the definition of a customer, a particular customer, or just a piece of little data that's in one column in the database that you want to share across instances of your component. And going to the database and getting it, in my experience, is the most scalable way to build your application. The other services that we provide that help you acquire state is object pooling. And object pooling is one of the places where we kind of relax the requirements that you don't have any state, because in fact the object is by definition stateful. And the difference is that you acquire an object from the pool which has state, and then you use that, and then you put it back in the pool to be shared by other components. And the requirements to be object pooled, the most important one is that it can't matter which particular object you get from the object pool. Everything in the pool is exactly the same. And this is one of the ways that we allow you to hold state yet still be scalable, because we can pick any individual one and share it across whoever needs it to do the work.
So in that particular object pooling model, like what's a scenario example of an application that might be using that exactly?
So a typical scenario would be that you are pulling an object that holds state, and the state that it's holding is a database connection, whether an ADO connection, OLADB connection, or ODBC connection. And that when back in the method call model I gave earlier for the COM+ programming model, you acquire the state, which in this case is you get an object from the object pool.
What's like an actual application, like a Barnes & Noble website or a human resources application internally on the intranet that would actually clarify what's going on with this object pooling?
So any application that does database access could use object pooling. Anything that wants to, has a piece of state that's expensive to get, expensive to create, that you use it for relatively short periods of time, and you use it relatively often, then object pooling is a win. One example that's been in the press a lot recently that highly leverages object pooling is the SQL Server TPCC benchmarks, where with SQL 7 and Windows 2000 we came out with the highest absolute number ever done on the TPCCs. And
TPCC is what?
Is an industry standard benchmark for measuring the performance of databases. And in TPCC you have thousands of clients that go over the web to an IIS server, and that in IIS is written so that the web application is written so that when a request comes in, it goes through COM+ to get an object from the object pool, and then it executes the object in the object pool holds state, which is a database connection, and it calls a method on the object which goes off to the database and does some work. In the past we used a variety of technologies for the middle tier, and with COM+, all the technology for building the TPCC benchmark from the client to the web server. The middle tier of the back end is entirely Windows DNA, and it is the fastest absolute benchmark that's ever been run, and also the cheapest one for cost performance.
And so that was combining both the statelessness of the objects as well as object pooling for those few instances we're actually needing to maintain a state in some fashion. Well, I mean, this still sounds like a fairly heady issue to deal with from an application programmer, and rethinking their model through to be dealing with COM and COM+ and statelessness and object pooling and stuff like that. What are some of the issues you think are important for programmers to understand that maybe haven't quite stepped onto this bandwagon yet?
So I guess there's two things I want to mention. Is that first of all, this is relatively complicated in the sense that the problem you're trying to solve is a complicated problem. You're trying to solve problems where you have hundreds of thousands, if not millions, of people who are accessing your server and trying to get services from that, and that as a complex problem typically yields complex solutions. But what we're trying to do in our model is make that as easy as possible to do, and that there are these fringe cases where you have to worry about fine tuning to get your scalability. But in the general sense, and I think we'll hear more about this in the next talk, it is really quite easy to build the COM+ applications, where you can write them in whatever language you want, compile them into COM objects, and then configure them to have whatever services they need. And in general, they will scale as high enough to run practically every single website in the world. Now, as you go through and you start scaling higher and higher, you start to need to get a little more sophisticated in how you build your application. We find typically that the first thing that people need to start worrying about as they start scaling higher is how are they doing their state management. And this is just something I wanted to highlight at the beginning. I didn't want to make it sound like it's incredibly complicated, but it's certainly something that you need to think about at the beginning. And if you focused on saying, can I make this component stateless? Can I acquire my state? Can I do the work I need to do and then put the state back? You'll go long on the way towards being able to build a scalable website.
So what are some of the other aspects then, besides statelessness, they need to be paying attention to in building a COM+ application?
I think that applications, again, we're trying to build here are scalable applications running in the COM+ environment. They need to think about the kinds of things they need to do now as opposed to the kinds of things they can do later. So immediate response versus a response, in a reasonable amount of time, but not right now. And the technology they could use to do that is through queuing technology. And we have something in COM+ called queued components, which allows you to build your applications exactly the same way you build them today. There's a few restrictions which we thought about are really quite natural, mostly in terms of not having out parameters. And then
not having out parameters meaning
you don't rely on somebody returning a value to you when you make a function call. And what queued components does is you simply check a checkbox again and says this is a queued component. And then when you make method calls on your component, we actually queue them up, where we note what method you called, what parameters you passed in, and we marshal them all into a buffer. And we actually use MSMQ as our queuing technologies. We'll put them into a queue, and then MSMQ will transfer that to wherever you've configured the server to be. And then we have technology on the other end, which will take them out of the queue, unpack the method calls, create your destination component, and then make all those method calls as if the client was actually connected to the server. And what this allows you to do, again, is free up resources on the server, because it's not sitting there waiting for whatever it's talking to return. It just queues up, the server can return and do somebody else's work, and then asynchronously that work is done kind of in the background in some sense.
So this would be an important aspect of in a disconnected state. If you want to be taking a running application on a laptop computer and be setting up some books you want to order or some insurance forms you're trying to file, and then when you connect back up to the system, the queue flushes out and all the processing gets done for you.
That's exactly right. So you can imagine building an application that you run on an airplane that you're not connected, and you make all the orders you want. You build up your purchase order, and then when you land, you connect your laptop to the web or to whatever network you have, and that queue will then play off onto the server. On the server, we pick up all of your purchase order and then play that against the back-end component that knows how to deal with the purchase order.
Now, with all this talk about the modern web application and connected, disconnected states and purchase order, things like that, one of the things that isn't too far from that discussion is the model of talking to systems that maybe aren't COM+ based systems. So obviously COM+ is a Microsoft Windows technology. What about issues where you're trying to access services and capabilities on a system that isn't running COM+? What are the options there?
So there's a bunch of options for you. There's technology through SNA server called COM+TI that gets you access to mainframes. COM+, a piece of the COM+ on my team is something called the Distributed Transaction Coordinator for doing two-phase commit across resource managers. And in there we have a bunch of protocols that we use to talk to a variety of platforms. So there's the TIP protocol, which is a transaction internet protocol, an HTTP-based protocol for doing two-phase commit. There's a variety of companies that have implemented that on their backends. Then there's also XA. We have XA support. So via XA support, you can get to virtually every single database in the world running on whatever platform you want to have. We also have this technology in COM+ called CRM, which is compensating resource managers. And what that allows you to do is in a very, very simple way, using whatever tool you want, Visual Basic is a fine way, you can build these front ends that allow you to simulate two-phase commit with whatever backend you want. So for example, one of our close partners, Microsoft, is SAP, and what they have done is used CRM to do two-phase commit in a demo actually over a year and a half ago in Atlanta, where they did two-phase commit using COM+ between a local version of SAP running on Windows NT and a remote version of NT running on HP UX, all coordinated via COM+ using compensating resource managers. With this technology, you could very easily tie together back-end systems that do credit card processing and reservations and whatever else you want.
Now, we've been kind of ignoring Paul here for a while here. You have a good habit of talking quite a bit, Joe. I'm just wondering, Paul, is there anything you want to add to what Joe's been saying so far?
Joe's doing a great job here. He mentioned a couple of times about performance and scalability and what a critical thing that is. We do find a lot of customers talking about, boy, I'm running in the mid-tier and it's expensive to go to that database and I've got to build my own cache, and I'm sure that's going to be cheaper to touch that locally on the mid-tier. And I don't have any of the statistics with me, but time and time again when we ask customers, well, did you actually try that before you made the decision to build your own cache? Are you sure it doesn't perform as well going and touching the database? No, but we're sure. And the reality is, in virtually every case that this has come up and we've done the measurement, going and touching the database has been cheaper than trying to find something locally in some homemade cache. Now, a couple of things that are going on there. One is, Joe said before, they're doing connection pooling. So they're keeping that connection open and keeping it hot and reusing it. The other thing that happens back on the server, the database server, is that the data that's being touched all the time is staying in memory. So it's not like you're going to disk. Going to disk is 5,000 times slower than touching something in memory. Going over the network would seem that it's going to be slower than grabbing it in memory on the same machine. The reality is memory isn't always super fast if you don't know how to write a good cache. Finding the right data in memory still can be quite tricky, and SQL Server happens to be optimized pretty carefully over the years to do that. So I'm not saying that someone won't bring a case forward where they had it highly optimized and it was faster, but going over a high-speed interconnect to a database that is highly tuned in terms of caching, where the data is already sitting in memory because it's being hit by literally tens of thousands or hundreds of thousands of transactions through the day, has proved to be an incredibly fast thing. And COM is an important component of that, as you stated, was proven in the TPC benchmark. And you mentioned it was 7.0. It was SQL Server 2000 on Windows 2000. So I wanted to correct that. That's okay. That's okay.
One of the things I wanted to emphasize that Paul was talking about is the customers who go through and think that they can build a cache better than SQL Server's cache, and that, I can imagine a case where they knew exactly what they wanted to do, and they wanted to write a single purpose cache that did nothing except access the one piece of state they wanted, that they could beat SQL Server's
pulling a
performance.
static page or something like that.
Something like that.
Yeah.
But what I find is that people go through and do that, and at some point they want to evolve their application.
Right.
And what they're doing is they're cutting off their ability to rely on us to build the infrastructure up. And one of the big advantages they get when they adopt the Windows DNA architecture is not only do they have all these rich set of services, from the web services to the data services to the object services, but they also can rely on us to go through and continually evolve the platform underneath them. And as long as they're working in our environment and they're following the rules that we've documented for how they should build their applications are only going to get better as the environment gets better around them.
So the key concept then is for the application programmer to trust their own best abilities, and then also trust others who have demonstrated best abilities in those aspects as well. So for like SQL Server and database functionality, why should someone just doing order processing algorithms worry about also creating a database and creating a cache when there's other companies out there that specialize in that
Writing
functionality?
a high-performance cache is something that 50 to 60 people in the world probably wouldn't know how to do, right? Eventually, what if I get too much data in that cache and that cache keeps growing? Well, then it's starting to starve other resources. You may actually be starving the very application that you're trying to make more performant. Well, maybe I need to spill things over to disk. Well, how many guys know how to spill it over and then pull it back, asynchronously and read ahead, and all the complicated algorithms that go into really tuning and making that stuff work? Believe me, if you're a high-performance cache developer, come and talk to me, because I'll give you a job. There's just not that many in the world, and the guys that do it extremely well. So while it is, counterintuitive that going back to the database server and getting something out of cache, a piece of data out of cache, and bringing it back into the application would seem like it would cost more, the facts don't prove that out, and we've measured it time and time again.
The one thing that seems to be, when people start going down the path of building their own cache, they start realizing, I need another feature, and they add the feature. And the feature that always gets them in the end is someone who comes, but either I want to query it, and they can't go to a query processor, or cache coherency is another one. This is a relatively large European exchange did this. They got the cache coherency. They spent all their time trying to develop cache coherency, and we went in and put SQL Server in front of it, and they found, hey, it's already faster. We can just forget that cache coherency problem, and we'll use SQL Server instead.
It's a slippery slope. I think that's the point we're making. If you're doing static pages, you never change them, you don't have to worry about locking concurrency and that stuff, you're probably going to figure out a way to make it really, really fast. If you're doing anything that might cause you to lock it or to share state between multiple different objects in the pool, or if you're doing anything where you're requiring any kind of update semantics, or if you're worried about the thing growing dynamically, where it starts to, maybe I need to spill it over, or it starts to grow dynamically in the memory, and you start squeezing out memory for the operating system or for COM. Believe me, think it through before you start, because there are many possibilities there that you haven't thought about.
So I was going to comment on this. We're trying to get at kind of the methodology of building applications and some things to avoid. And there's two things that I wanted to bring up that customers seem to make the same mistakes over and over and over again. That if we can just get them to think about these two things, we could probably make their chance of success orders of magnitude better. And the first one is, don't make your prototype your application. Is that Windows DNA is it's so easy to get a prototype up, and that in fact, people come to us and say, it's really hard to build applications in your environment, Joe. And I'm saying, well, actually, I think it's too easy, and that's why it's so hard. It's really, really easy to get out, get 3 people in 3 weeks build an application that you'd be amazed at how well it works. The problem is that it's still a prototype. Everything you learned a lot as you went through the first time and built it, and that the IT managers might love it because it looks like it's exactly what you want, but you haven't thought about some of the issues. And so I believe it's very important to learn from your prototype and then start over again and think about what your ultimate goals are before you go. And the second thing that people make as a critical mistake to their success is they don't stress test before they deploy. They just deploy it automatically when they're done. Works on my client, it must go,
Right.
and they roll it out to 10,000 clients, and they have these huge, enormous deployment problems.
We'll talk about scale too. Are there some things that people, the thing I see when I go run into customers is that they don't think about scalability and what the application may have to scale to before they start.
Right.
So they design it to kind of work, but they don't think about, ooh, what if I have to be doing, 10 million hits or 50 or 100 million hits in a day? And are there some design points that you should look at in terms of scalability?
Yeah, so scalability is really gets back at the two things we talked about earlier, which is one, if you build for stateless applications, that's kind of like the prime scalability thing, and this gets back to you have 10 million hits, and if you got to go and hold on to state and everybody's holding on to state, all of a sudden there's no more resources on the server to satisfy the hits because all of your resources are being consumed by trying to hold on to state. So you want to share your state across those 10 million hits, and you need to do that via stateless. And again, Frank will talk about that. And then I think queuing is another really important thing. Do things later if possible. Dump them into a queue and let the queue play them back in the background. I think also it's important to spend a lot of time designing your back-end databases, and that this kind of what we need to do is kind of grow what the concept of an application is, and that it used to be an application was just this Windows desktop or even the DOS thing. You're the only thing running on there. You don't have to worry about anything else. Windows introduced this idea that said now we have this cooperative multitasking, and you really shouldn't inside your paint message go through and spend 15 minutes doing something because no other application is going to run this machine. And now as we've gone from DOS to Windows, now we're on the server and we're talking about a couple more things you need to think about. You need to think about how do you relate with the database? How do you relate with your IIS? How do you bring all of these things together? And growing your application design point to include how IIS works, how your components are going to work inside of the services, and how this is all going to interoperate with the database in the back end, and tuning this as a unit, I think is another way you can get at the scalability. And I think Paul's right. You constantly need to think about, am I going to get to 10 million hits? Am I going to get to 100 million hits? And how is my application going to work in that environment? And I think building stateless, building queued applications, and then stress testing, hit it with 10 times more clients than you need to. If you go to MSDN, there's tools we have that will allow you to simulate client load. And if you have 10 times the clients that you can ever possibly imagine are using this, and then you become successful, by the time you get those number of clients, which probably won't be that long, you can do what you need to do to get the next 10 order of magnitude more clients accessing your machine.
Just because it's easy to build the app doesn't mean that it's automatically scalable. We try to do as much we can in the infrastructure to make any application scale, but doing it quickly and not thinking about the application at systems level, not thinking about recovery, not thinking about just kind of disaster recovery, not thinking about backup and recovery and any of the things that just kind of are fundamental to highly available systems, or just flat out scalability. How am I going to add another server? What's that going to look like? What's the database? Does the database need to be partitioned at some level? Those things become incredibly important. And just because it's easy to check a box doesn't automatically make the application scale. We try to make our tools easy, but again, it doesn't replace good systems level engineering.
So good programmers is what we need.
Absolutely.
Just because writing some of this code might be easy doesn't mean we're suddenly opening up the door to every Tom, Dick, and Harry that knows how to spell Windows or whatever on their system.
Right. We had a customer come forward recently and was using data replication in the database. And they were very angry, and they said, oh, our website slowed to a crawl, and we just couldn't figure out what had happened, and your product is broken. And well, we started asking a few questions, and we thought maybe there was a serious issue. And it turned out, we finally asked, well, before this big slowdown in your website, did any event occur, that may have caused things to slow down? Well, we did delete 4 million rows on a server that was using data replication. Well, it was easy to set up replication. It took 10 minutes. But when you delete 4 million rows, that's 4 million replication events that the server's got to service, in addition to servicing all the customers that are coming in. So you still have to think about, what's going on in your environment, when to schedule. It would have been really easy to schedule those deletes, at a later time. Or honestly, there's another method they could have used, where they would have replicated the stored procedure, and then deleted the 4 million rows on the other machine, and none of that would have went over the network. So there's many, many, many times very simple workarounds, but Sometimes the fact that we make it easy to build the application quickly kind of works against us because the developer doesn't always take the time to think it through. Not blaming the developer.
Yeah. Well, just like back in the old days on the Apple II and stuff like that, we only had like 48K in memory. Programs could be really small, tight code, and nowadays with megabytes and megabytes of memories and gigabyte hard drives, it's like we fill the whole sucker up, and so people aren't quite learning the same optimization techniques and understanding the technologies. And it sounds like COM+ is just further enhancing this. So, write small granular applications that are procedural based, you're stateless, you're maintaining queues and that sort of stuff, and then rely on people that can really develop the services for you and the infrastructure rather than developing it yourself.
Sure, and think at a systems level. I think end to end. I think that's kind of a key thing. And do the stress testing, as Joe says. Many times that's what we end up doing when a customer falls down. We end up pulling the whole application back in our lab and running it up under high levels of stress, and then start to find out areas where things aren't going well.
So what does the future of COM+ hold for us?
So the future is mostly more and better. We have a team building applications right now. We're adding more services. One service that you'll expect to come out with a subsequent release of Windows NT is something that allows you to be more resilient to memory leaks, where we will put your application in a process pool. So before we had thread pools, and in COM+ 1.0 we had object pools. Now you're going to get process pools, and we'll recycle those applications inside those pools.
It's one big pool party, it sounds like.
One big pool party. One of the things that we're looking at is that we have a catalog where which is essentially a database where we store all the configuration data. And what we'd like to do is, take our own advice and say, where does data belong? Well, it belongs in the database. And so we're looking at trying to get that into a version of SQL Server so that, that basically opens up the black box and allows you to look at the data in a more seamless way and better management tools at it. We're constantly trying to figure out ways that we can make it easier to deploy the applications, and once they're deployed, to be able to get kind of a sense of the health of the application and be able to monitor the application and then dynamically fix problems before they occur, so that we can make the actual running of your site easier. And you should expect to see more and more of those services come down the line.
Well, thanks. I mean, it sounds like just constantly improving the underlying services that we're getting used to using now in our applications today. I appreciate the time you've spent with us today, and hopefully we've clarified some issues that programmers might need for adding COM+ to their application. Well, that's COM+ in a nutshell. Hopefully we touched upon the issues that you're needing to understand to better incorporate COM and COM+ into your applications moving forward. Stay tuned, and we'll soon cover the programming aspects you need to see and actually be showing you code.
We had some guys at Microsoft came and said we should do a console. And at first we were saying, well, wow, that sounds like a real challenge. Could we really make a contribution? Could we do something that's over twice as good as anything out there? Could we do something that's really explosive? And so we went off and studied that. We talked to a lot of partners. We talked to a lot of game developers. And they came back and they said, yeah, there's really an opportunity because of the internet, because of leveraging some things on the PC, because of some breakthroughs, to do something that is dramatically better. So what I want to go through here is my excitement about this new product, and to make it clear the incredible commitment that we have to this product. So I'm announcing the Xbox, the future of console gaming. We don't have the box, but we do have the leather jacket.
This obviously is the Sparkler demo. We have all of the features of the other demo you may have seen. It has the gap commercial mode, very, very important. Ours does some cool things. It shoots colors. It'll go around in a circle. It'll go around in a circle and it'll shoot colors at the same time. And all those are pretty neat. I mean, whatever. The most impressive thing about this, though, is that this took a developer an afternoon to create. In my high school physics class, I was scarred with the image of chain reaction as demonstrated by the old ping pong ball and mousetrap demo. So I felt it was only appropriate that I would scar all of you today with that same image. And I'll let it speak for itself. I'll launch the ball. Now that's a lot of stuff going on at the same time. Again, a great example of the CPU doing all of this collision, all of this physics at the same time that the graphics processor is rendering the scene for us. What's that? What's going on up there? Some bugs in here. Oh, they're butterflies. Looks like they all have shadows. Kind of scared of the camera. I'll look up and see. Oh my God, there are a lot of them. And they all have reflections. Now, I thought this demo was really cool, and then I realized that, in fact, the butterflies are big supporters of Xbox as well. And I'll let them speak for themselves.
Ladies and gentlemen, the new, undisputed champion of the world, Afro Thunder!
Somebody better call the doctor! I'm cleaner, faster, and prettier than ever. On today's system, I grew. But on Xbox, I come alive, baby! My muscles are tight, my action is fast, and my punches can only be seen through motion blur. I got over 20 megabytes of texture, and I'm not even breaking a sweat. And thanks to programmable pixel shaders, my face is smoother than a baby's behind. The power of this sucker even lets my froze natural pulse to show through. Try that without full scene anti-alias. I'm rippling with Beziers, bending with multiple matrices, and slamming with ultra-fast programmable hardware T and L. And with Xbox's lighting power, I can show off my glistening smile like never before. Take it from me, Xbox is gonna rock your world!
Let's get ready for Xbox!
Yeah, baby! It's time to dance, it's time to dance!
So hopefully, you now understand a little bit more about the architecture of COM+ and why it should be important to your applications. But as always, understanding the architecture is only half the battle. What you really need to understand is how to program to that architecture, how to write code that uses COM+ in your applications. Here to share his knowledge about the programming of COM+ is Frank Redmond. Frank, I understand you're a program manager for the COM+ team.
That's good.
And
Yep.
COM+ is very important to you.
Absolutely. Before I get started, I just want to drive home the point. Listening to Paul and Joe talk about COM+, one of the things that is critical that a lot of times developers miss is that COM+ is about building scalable component-based applications. Okay, so it's a combination of two things. You want to build an application that's component-based first and foremost. Okay, and then the second aspect of that is you want that application to scale. Okay, because hopefully what we'd like to have is people building applications that may start off small, right? It may start off with 10 or 20 users, but hopefully as that business grows, we want to be able to grow the application as well. We don't want to have to go in and rewrite that application, right? So you'd rather throw hardware at the problem in that scenario. So that's what we mean by scale. You build this application for a small number of users, and then as your business grows, so can your application without having to go in and redesign it and re-architect it. I think that's a very critical piece. We provide those services that you need to be able to build scalable component-based applications.
So, I mean, this model then of scalable and component-based applications, who all does that touch? Who all should be focusing on that sort of capability?
Pretty much that's everybody in the world out there wants to build scalable component-based applications. When you think about anything that may end up in an intranet scenario or department level, all the way up to full-blown internet services that may have millions of users, right? You want to build those in scalable component-based applications.
So are all these people creating component-based applications that are scalable? Or, I mean, are there some people that aren't doing that yet?
Today we see a lot of people that are we see some people that haven't made the leap to component-based applications. Clearly everybody recognizes the need for scalability, but there are still some companies that are out there building largely script-only applications, right, that have just ASP script going against a back-end database like SQL Server, and that will scale, but then you have to factor in the components brings reuse of code, encapsulation, reuse, things of that nature, right? It's compiled code versus script. Script is late bound and all dynamically executed, right?
Interpreted.
So it's all interpreted. So you've got the fact of you've got a comparison of what's the word again?
Interpreted?
The interpreted versus the compiled code is the difference. So all of the things that we learned from going to component-based models when we first introduced COM, we want to take all of those benefits and apply them in this new world of highly scalable component-based applications.
So why wouldn't people be focusing on component-based applications? What's preventing them from doing that then?
Well, a lot of times the services provided by just base COM were not enough, right? So then we introduced some of the services in MTS, right, that component developers could take advantage of to build more scalable applications. Services like transactions, thread pooling, database connection pooling, those are the kind of services that developers found very difficult to write in order to be able to continue to build component-based applications that also scaled well. So we continue to provide more services in COM Plus that will help developers build these component-based scalable applications.
So what you're saying then is that COM itself allowed component-based applications to be developed, but people weren't jumping onto that bandwagon because it was difficult to encapsulate the full component object model within an application scope. And then COM Plus is then providing the services that try to make that as easy as possible.
Absolutely. So a lot of people develop great COM applications from a desktop application perspective, but now those same developers want to leverage what they've already learned in building great component-based desktop applications to be able to build these new highly scalable component-based applications. So leveraging their existing knowledge and infrastructure of COM in terms of they know how COM works, they like the tools that are provided to build great COM-based applications, but they needed those applications to be highly scalable now. And it was very difficult with just base COM to be able to build these highly scalable component-based applications. So MTS was one of the first steps that we took to be able to provide these services that developers need to build highly scalable component-based applications. COM Plus now follows that up to be able to provide more services. So that's less code the developers have to write, maintain, and debug and carry forward. That's less code they have to write to be able to build richer functionality applications that are more scalable.
So Frank, can you show us a little bit what it means from a code standpoint for programmers to actually add COM Plus functionality to their applications?
Sure. There's a lot of different services in COM Plus, and the one I want to focus on now is queued components. Before I jump into some code, I want to kind of tell you a little bit about the architecture of queued components, and hopefully it'll help you better understand the demo that I show in a second. So the way queued components works is today we have DCOM as a way to communicate between two machines, to be able to activate a component and call methods on that component remotely. And DCOM works great, and typically in an intranet scenario, in a connected synchronous execution model, which means that from the client's perspective, the call to the remote server is going to execute synchronously. Okay? And that the client and the server machines have to be connected at the same time in order for DCOM to work. And that fits a large model of applications. But in today's high scalability world, people also want to have asynchronous execution in their application designs. So we wanted to make it as easy as possible to introduce asynchronous asynchronous calling inside the COM model.
And by asynchronous, what do you mean exactly?
What I mean is that I can start some work, I can make a method call to start some work to begin an operation, but then the client code continues to execute and the server may process that work at a later point in time and return the results to the client at a later point in time.
So it'd be kind of similar to when I pay my bills and I take the check and stick it in an envelope and put it in the post office box. I don't have to wait for that check to be drawn out of my bank account. I just happen to know at some point in the future that check's going to come back through my bank account and take the funds out.
Absolutely. It's kind of like another way to think about it is it's kind of like email, right? If I send you some mail and I ask you to do something for me, you're not going to do it when you open that email. Right?
Of course not for you anyway.
Well, not for me. What you're going to do likely is you're going to open up that email, then you're going to schedule some time when you have time to actually fulfill the request. And I understand that when I send you the email that request is probably not going to be processed in your case for several months.
You know me too well, Frank.
So that's kind of the way queued components works is that developers want to make a call against a component and then have that component go off and do the work, fulfill the order or the request, and then send back the results to the client via some other mechanism. And it could be they could send that message results via email or queued components going back to the client or something like that. The major pieces we want to talk about are, from the client's perspective, there's a special kind of a proxy on the client's machine that the application talks to. And what this special proxy is actually a recorder. So all of the interaction that the client wants to make with the object is actually recorded. Okay? Then once the client signals it's done with that component by calling a final release, at that point in time, we'll take all of that interaction with that particular component, all of the method calls, the sequence of method calls, as well as any parameters that are supplied to those method calls. We'll put those in a single Microsoft message queue, and we'll put that on a queue on a local machine. Later, at a later point in time, that message will find its way to the destination queue in the enterprise space if the machine is reconnected to the network. There's a special component called a listener that is always, it's asynchronously listening on a queue in the enterprise space. When the listener picks the message off of the queue, it will then forward that message to a special stub called a player. The queued component player will then unravel the contents of that message and actually drive the component by calling that sequence of methods with the parameters that the original client provided to actually drive that component at a later point in time.
So similar like to the macro recorder in Excel or something like that, where I can record a number of steps I want to perform upon a document and then play those steps later on. This is just doing it from a programmatic standpoint, from application to application.
Absolutely. And so the developer doesn't have to write the special proxy. They don't have to write the listener. They don't have to write the special stub. They don't have to write the infrastructure to use MSMQ. All they have to do is follow some specific guidelines, essentially, that say they're not going to provide any out parameters, okay, and that they will only be calling functions on those components that they mark as being queuable. At which point in time, when they install that component, the Component Services Explorer, using the Component Services Explorer, the COM+ infrastructure will take care of all of that stuff behind the scenes. So it's very little code the developer has to write. What we're going to look at now is we're going to actually take a look at some code here that shows a particular business process being implemented. So this is the code that's trying to be called by the client. And it's called process orders, just a simple example, but it reflects kind of what happens when you have kind of an e-commerce scenario on the web today, where you fill out some kind of a form, usually in HTML, right, and then that form is sent to the browser, sent to the server, okay, at which point in time you'll pick that request off and you have all of the original parameters in the form, and then you actually process that order. So the client may fill out the request while they're connected to the server, but that request is probably not going to get processed for some time down the road. So here, in our simple example, we simply display a message box that will tell us that we've completed the order has been processed, and we'll display the order number and the customer ID. Okay? So we've implemented this, we'll build the DLL, and then we'll register it in the Component Services Explorer. So I'll go here, and I'll create a new application, create an empty application, and I'll call this one the QC sample services. Now I've got my application, the QC sample application, and I'll register those components that I just created. Now, for those that are familiar with the Component Services Explorer, you'll see that I have the component installed here. I can go here and see all the interfaces, and I can even expand out and see the various methods on those interfaces. So what I've done is I've just registered the application. I haven't created any queues or anything like that. So now I need to tell CommPlus that that particular application supports queuing. So I go to the application, I'll right click, I'll select properties, and you see here I have a queuing tab. Now, if this application is not able to be queued, then this particular selection will be grayed out.
And by not being able to be queued, what does that mean exactly?
That means that you haven't followed the parameters. You have functions that return values, or you have some in-out values or something like that.
Okay.
As long as you have only in values and you don't return any return results, then your application and your components can be queued.
Mm-hmm.
So when I click this button that says I want to be queued, at that point in time, CommPlus will create the various MSMQ message queues that are needed to support the application.
So it's just got through building the infrastructure for this application to accept a queue, so another application can talk to it through the message queue.
Absolutely. And if I pull up my computer management tool here and I look at the public queues, you'll see that I now have a queue here called QC Sample Services, which is the name of our application. So the queues are named after the application that I just created. And if you look in that particular queue, you'll see I don't have any messages yet. So now I've got the application created. Microsoft Message Queue queues have been created on the machine. Now I need to specifically tell CommPlus which interfaces on which components do I want to support queuing on. So in this particular example, I have two interfaces here. I will pick the iOrder Services interface. I right click on it. And when I select properties, you'll see I have another queuing tab. Now I'm saying I want to mark that particular interface as supporting queuing. So queuing is applied on a per interface basis.
So first you mark the application as being capable of being queued, and then you identify the individual interfaces within that application that are going to be queued?
Right. So I'll select that this particular interface supports queuing, and that's all I need to do. Now let's take a look at what the client-side aspect is. What does the client need to do to tell CommPlus Services, I want to create that component in a queued fashion? Because just because a component supports queuing, you don't always have to call it in a synchronous fashion, in an asynchronous fashion. You don't always have to use queued components. You could choose to create that component via DCOM, in which case the component and the client would need to be connected, and it would be a synchronous method call. So I have a choice from the client perspective, based on how I create that component, whether or not it will be executing synchronously or asynchronously. So let's look at the client-side code. What I have here is a simple Visual Basic front end for this sample that allows me to enter a customer ID, an order number. Then I can select various line items that I want to add to the order and identify the items by their number, and I can tell the application the quantity of each item that I want to buy as part of this purchase. What's interesting is on the process click event. You can see here.
So it'd be the same thing as clicking the submit button on an HTML form.
Absolutely. So what I do here is I do some basic variable initialization. Then I get the customer ID and the order ID that have been entered on the form. I then get the values for the various line items. And here's the part that's interesting. I create this object. VB users will be familiar with the create object call that I'm making here. But you'll see what's interesting is this queue prefix and this new prefix. Now those are two monikers that I'm combining to tell CommPlus that I want to create a new instance of my QC Sample Services Order Services component. I want to create a new instance, and I specifically want to create a new instance that is queued.
So this application is specifically designed to use queuing for its communication to the server application.
Absolutely. Once the component is created, well then I just make regular method calls against an interface just like I normally would my day-to-day comm programming. So let's run that and see what happens. I'm going to enter my customer ID of 100, and this will be my first order. And I'm only going to buy one item of item 1. So when I click on process, we would expect the message box from our process order to come up. But as we see, it has not come up. But when I refresh the message queue and look at those contents in the queue, you now see I have one message in there. That's because I have activated this component in a queued fashion. The server application is not yet running, so those messages are now just sitting in the queue.
Sitting in like your outbox in email if you were taking email.
Absolutely. So in this scenario, it kind of shows what would happen if I were in a disconnected laptop scenario, okay, or for whatever, maybe I have a network outage or something of that nature, or I'm choosing to process orders during an off-peak time. Okay, so right now those messages, all those orders are going to just sit in this queue till a later point in time. And we'll put a couple more orders in there. For order 2, we're actually going to buy 10 units of item 1. We'll process that, and again, if I look in the messages, in the message queue, you'll see I now have 2 messages. Okay, so now we've got all our orders in, and it's some off-peak time, and now we want to go process those orders. We actually want to fulfill those orders. We want to make sure that we have the quantity in stock. We want to validate the credit card and actually charge against that credit card to actually purchase those, purchase the contents of the order. So the first thing we have to do is we'll go back to the Component Services Explorer, to our QC Sample Services app. We'll right-click on it, and on Properties, I'm going to go back to the Queuing tab, and now I'm going to turn on the listener.
And what does that do?
Now earlier, if you recall, we talked about the listener that asynchronously watches the queue for incoming messages. Well, now we're actually going to turn that listener on, because typically the listener is not running unless you specifically tell it to again, conserve those server-side resources. So we'll turn on the listener. The application won't listen until the next time we start it. So just by turning on the listener doesn't actually cause it to listen. You have to now start the application. So now when I go here and I actually start the application, you'll see that those orders have been processed.
Now, in this example, you used the Explorer there to do a bunch of administrative stuff to the application to turn on the listener and get it started again. Now, if you were using a real web services model, does that mean an individual would have to come to the computer and turn on the listener and turn on the application every time they want it to go?
Absolutely not. While it could definitely be done manually, I could script those services those operations that you just saw me perform. So I could pull up a notepad and write some VB script in it, and then I could execute that using the Windows script host, right? And what I would do, the script would simply simply turn on the listener and then start the application. So that the administrator could just double click on that script to actually cause the orders to be processed. The other thing I could do is I could take that same script, and then using the Windows scheduler, I could schedule that script to execute at predefined times throughout the day. So that's pretty much the way Queued Components works. You saw it was very simple. I didn't have to go into any new MS&Q APIs or anything like that. From the component developer perspective, I use regular COM creation APIs. I used the queue new moniker to say that I wanted to create a new instance specifically, and I wanted it to be queued. And then I made method calls against an object interface, just like I normally would in COM. I had some administrative things that I needed to do in terms of when I registered the application, I needed to say that that application was queued, and I needed to mark the various interfaces of the components in that application that I wanted to support queuing.
Now, from the code we saw, there wasn't an awful lot of difficulty involved. There's just a couple lines of code that are actually implementing the queuing capabilities. So what I'm taking from that and what we've been talking about, COM Plus being kind of difficult and that sort of stuff to work with all the time, it's not so much the code you're writing, but it's the way you write your code to use this mindset of a queued model.
Absolutely. While you don't have to spend as much time writing the code, you should take that time to spend more time architecting and designing your application so that you can get increased scalability and increased availability, increased reliability, things of that nature that most application developers want to get, and it's critical in the web space. So the next service that I want to talk about is events, COM Plus Events. So what COM Plus Events is it's a more loosely coupled publish and subscribe eventing mechanism. What it allows you to do is have a single publisher. From the publisher perspective, you fire one event, and you fire that event into the COM Plus eventing infrastructure, at which point in time, the eventing infrastructure will iterate through all of those people that are interested in receiving notification of that event. Okay? So people that want to know about an event are called subscribers. Those subscribers build subscriptions and register those subscriptions with the Component Services Explorer, okay? Or with the COM Plus registration database.
To a certain extent, that sounds very similar to queued components, where you had, someone that was taking and submitting a method call to an interface in an application on a server. Now you've got a publisher that is publishing an event to a subscriber, and it sounds very similar. What's the difference?
The difference is that queued components is specifically a way to communicate with a component in an asynchronous fashion using Microsoft Message Queue infrastructure. Eventing is more of a way to deliver events in a publish and subscribe kind of metaphor. So queued components can be used to communicate between applications. Events is typically used as a way to provide application-specific extensibility points inside your application, so that at a later point in time, when you decide to add more functionality, you have this pre-built extensibility mechanism that you can hook into, so that you can evolve your application and add new and better services without having to go back and open the application back up. It also allows you to tie together in this very loosely coupled fashion multiple applications. Okay, so I could write some simple script code or something like that that will tie together two applications. So for example, when I add a new user to application A, suppose I want to make that user automatically be added to application B as well, so that I don't have to go perform two administrative functions. Right? By simply subscribing to the add new user event of application 1, I could write a simple subscriber that would automatically add that particular user to application 2 or application B as well.
So what I'm hearing then is the main difference is that with a queued component, the application that is firing off the queue is expecting there to be someone on the other end to then take that message in the queue and do something with it. Where with events, that expectation doesn't necessarily exist. He's just providing that if anybody's interested.
Absolutely. There doesn't have to be any subscribers. It could be 0 or more subscribers to a particular event. From the publisher's perspective, you don't really care. You just want to tell whoever is interested in the event that this particular event has occurred.
Okay, well, let's see some code on this.
Sure. What I'm going to do is I'm going to define an event class that will allow subscribers to subscribe to either a post-order processing event or a pre-order processing event or a post-order processing event. So the first thing we'll do is we'll create a new project in Visual Basic. So we're going to have a QC sample event class interfaces. So the first thing we'll do is define the various events that we'll allow people to subscribe to. Okay? And in this case, okay, so here's my pre-process order event, and then I'll also have a post-process order event. Okay, so now I'm just defining various events, and these will be on an interface that we'll call IPO events, which is short for the interface for purchase order events. Okay, so now I've got my interface defined. I'm going to save it. No, I'm not going to add it to source safe at this time. And I'll actually compile that. Okay, great. So now what we've just done is just simply define an interface. What we need to do, though, is we need to tell COM+ about that interface so that it will dynamically build what's called an event class. And that event class that it will dynamically build will implement this interface. And in its implementation, it will actually iterate through all of the subscriptions and notify all of those particular subscribers based on their subscription. Okay, so from the publisher's perspective, you always notify one subscriber. You always notify the COM+ event infrastructure. And then in the COM+ event infrastructure, the event class specifically, will then handle the iteration and notification of the various subscribers.
So that means that the applications involved, the developer writing the applications involved, doesn't really have to be writing all that code for doing all that enumeration and detection of events and so forth.
Nope. So now what we'll do is we will register our event class that we've just created. We'll create a new application to contain the event class. This will be our QC sample event class application. And now, when we right-click to install some more components, you'll see that we're going to install some new event classes here. Okay? And we'll go to our event class interface that we defined. We'll tell the system about it. And that's all we need to do. Now, at this point in time, COM+ has actually dynamically created the class that will enumerate through all of the subscriptions in the database and actually notify those various subscribers of the occurrence of some event. So now what we need to do is go back and write code inside the publisher, inside of our publisher, to actually tell the eventing infrastructure of the occurrence of the event. So I'm going to go back to our service that we provided. And the first thing I'm going to do is include a reference to that event class interface that we defined. Now, inside of our process order, what I'll do is I'll create an instance of the event class object. I need to go back and fill that in. One quick way to make sure that we get the right event class name is to simply copy it from the COM+ Explorer in this case.
That's cheating, isn't it?
Oh yeah, well, developers are always looking for an easier way to write code. Okay, so now we've got the event class object created here. Now we need to simply fire the event. So I'll put a comment in here so that other developers can maintain my code. Okay, so we're going to fire the pre-process order event before we fire off our message box. Okay? And then we'll also fire a post-processing event so that people will know about that one as well. Okay, and we'll save that, and then we'll build it. Okay, so now we've implemented the event class interface. We've actually we've modified our process order functionality to actually call this pre and this post, to actually fire this pre and this post event. So now what we need to do is have some subscribers that actually listen to that event and do something interesting in response to that. So we're going to create a simple subscriber here. Again, I'm going to create a new ActiveX DLL, and this one I'm going to call my QC sample subscriber. And this will be my purchase order subscriber. I'll include a reference to the event class interface that we defined, because that's the interface that we will get called back on by the system. Now we'll implement the interface. And inside of our pre-message, we'll simply just pull up a message box that tells us that we got the pre-process order event. And we'll do the same thing on our post-process order event. We'll just simply pull up a message box that tells us that we got the post-process order event as well.
And obviously, we could have just as easily actually put real code in there that did something on a server or recorded something in a database or something like that.
Absolutely. So now we'll save our subscriber, and we'll actually compile that now. So now we've got our subscriber built. We need to build a subscription now. We need to tell the system that that particular subscriber wants to be notified about the various events that we've published.
And I assume that this, again, is something we register with the Component Explorer.
Absolutely. And again, this can all be automated with scripts and things of that nature for setup and install and things of that nature. So again, I'm going to create an application to contain the subscribers. This will be my QC sample subscriber application. And inside my QC sample subscriber, I will add those components, the subscriber code that we just wrote. So now we have the components of the subscriber registered with the system. Now we need to actually go in and build subscriptions. You'll see here under the component I have an interfaces folder and I have a subscriptions folder. I'll right click on that subscriptions folder and create a new subscription. You can see here that I have a bunch of different interfaces that that particular component implements. So what I'll do is I'll select the particular interface that implements the various events that we defined. And the system goes out and finds all of the publishers that publish events using that particular interface. So for instance, 10 different components in the system may provide notification via that interface, but I may only want the one provided by Microsoft or the one provided by a particular company. So I can still pick out specifically which publishers' events I want to subscribe to. Now I'll enter a name for my particular subscription. And I'll enable that subscription immediately. And that's all I have to do. So now we'll actually start our client application up and we'll fire some events. My customer ID is 100. This is order number 3 now. And this time I'm going to buy 5 units of item 3. Now when I click process, again, nothing happens because that information is being sent to the message queue. I haven't started up my application listener. So if we look at our message queue, you'll see that particular message, that particular queue now has a message in it. So we'll go back to the Component Services Explorer, to our sample services application. We'll turn the listener back on, and we'll start our application. And this time, what we should see is we should see the pre-notification message box of our subscriber. We should also then see our message box of the process order that tells us that we've processed the order. And we should also see our post notification as well. So I'm going to start that application up. And you can see here that it got the pre-process order event. When we close that, you can see that it completed order number 3 for customer 100. And then you can see here that it got the post-process order event as well.
So I guess one thing that this illustrates then is that for something like placing an order, that probably is not the sort of thing you want to do as an event model, because when you place an order, you really want to take and know that there's someone on the other end that's going to be listening to it, and the event does not have that situation. However, for that service to simply be able to say, oh, something's going to happen, and then, oh, something did happen, that could easily be an event because you're not needing to actually have that be something that is constantly communicated back to the user or something.
Absolutely. So a good example of things that people do typically with this is they do logging as an extensibility mechanism. And what they'll do is when they design their application, they can focus on specifically what events do they want to make available to subscribers to be notified about. So that's where you should focus your time. You don't have to write infrastructure code to actually then perform the notification. We'll handle the subscription registration mechanism via the Component Services Explorer. We'll handle the deregistration mechanism, and we'll also handle the iteration code as well via the event class object that's dynamically generated when you register your event class interface.
So then, with writing complex applications basically being so straightforward, as long as you've got the design and the architecture down properly, what do you think are some of the key things that you want to communicate to a developer to help them understand how and why to add complex services to their application?
So even if you look at basic COM, the evolution from COM, where we provided the basic component object model, a binary standard for interoperability. So even if you look at basic COM, the basic COM programming model, COM had basic services, right, for object location and instantiation, and for cross-context and cross-process marshaling. Those are basic services that COM provided that allow people to build great component-based desktop applications. Then MTS came along and provided some of the basic services that were needed to build scalable component-based applications. Services like role-based security and thread pooling and database connection pooling and things like that. Now COM Plus adds on top of that, right? So it's kind of can be looked at as version 3 of MTS, right? So even though it's COM Plus 1.0, it's really the 3rd generation of our app server platform. Okay, and we provide even more services in terms of object pooling, more concurrency, more control over concurrency, things of that nature. more higher level application development services like events and like queued components. And down the road, we're just going to continue to provide more services for developers to tap into so that, again, that's less code they have to write, which is critical when you talk about increasing time to market pressures.
So for those viewers in our audience who haven't yet started doing COM and COM+ programming, what do you think are the best resources for them to refer to?
The platform SDK is probably the best resource out there. There's also a great Introduction to COM+ book that's out available from Microsoft Press. Those are both excellent resources to start actually looking at and getting your feet wet with the new COM+ services.
And I suppose if I ask you really nice, you'll save these files out so I can take and provide a zip file to my users so they can actually see some of this demo code that we just saw here?
Absolutely.
But I got to ask real nice, right?
I'm waiting.
Okay. Please, Frank.
No problem, Rob.
Okay, thanks. Well, hopefully this information has provided you some insights of how easy it can be to actually add the COM+ code to your applications. Of course, the hard part is making sure that you design your applications in such a way that they can take advantage of the COM+ services. And that's the part where programmers really can step in and make a difference in the applications they're writing. Well, thanks, Frank, for joining us, and thanks, audience, for listening. That's the end of the COM+ show. See you next time. Microsoft, of course, develops applications, software systems, technologies, and so forth. But what you may not realize is in order to support the development and distribution of all that software, we have to take and get our message out to people. Well, one of the ways we do that is with a new facility we just got through building, a large conference center. Now, this conference center is managed by Bill Nagel, and I have Bill Nagel here to talk to us about, what all this means and how the conference center works and a little bit about yourself. Now, I do happen to know a little thing about you, and that is that you happen to like wine.
I do.
So,
I love wine.
In order to help us with this little conversation here, I brought a nice little bottle of Saintsbury Pinot Noir.
Very nice bottle. Thank
Okay.
you, Robert. I love doing interviews with you. Anyways, I wanted to welcome you to the Microsoft Conference Center. We've been open for only 2 months now, and this facility was built by Microsoft to support Microsoft-centric events here on the Microsoft campus. Basically, on the main floor here, we have large rooms like the Cascade room that we're currently in here. We can seat about 150 people. Upstairs, we have the Executive Briefing Center, which has smaller briefing rooms. We have the Microsoft Home upstairs also, and a couple of video teleconference rooms.
Microsoft Home, what exactly is that?
Well, that's a digital home. That's where, you haven't been there?
Digital Home, like,
After we drink some wine, we'll go up there and I'll show you around. The Microsoft Home used to be over in Building 15, and it's where we show Microsoft technology for the home as far as controlling your lighting, your audio systems from the comfort of your video projector in your video room. And it's a wonderful facility. We can go up there and check it out if you'd like to. In fact, to get into the facility, you have to go through that eye retinal scanner thing.
Oh, that sounds like fun. Just like
wonderful
James Bond.
technology. You bet. Anyways, Prost. Thank you. Nice Pinot Noir here.
So I guess a facility like this probably took a while to build.
Yeah, without a doubt, Robert. This building took about 4.5 years from start to finish. A lot of people involved, real estate and facilities. Microsoft Studios had a lot to do with the design of the AV infrastructure. In fact, we have a digital backbone at this facility with fiber connectivity back to Microsoft Studios so we can stream content back and forth as needed.
Oh, really?
Yeah, we were lucky enough to enlarge the conference rooms and the scope to be able to house larger conferences and bring back onto Microsoft campus a lot of events that were too big to hold here on campus. The first floor here, we can get about 3,500 people total. We have 9 rooms here on the first floor. 7 of them are flat-floored rooms, multi-purpose rooms, and 2 of them are like this room, sloped-floor auditoriums. There's a Crestron touch panel up there. We can hook up to 32 different demo computers if we have to, and this room can be run by an operator in the back of the room too, in the control booth if we have to. But each one of the rooms, as you can see, we've got these robotic cameras here which go back to our video production room, so we have a technician that sits back there and can operate the cameras from there and videotape the events that happen and the content that happens within this space.
So with the robotic cameras, that means we probably could have filmed this interview using them rather than this crew that we're paying an awful lot for.
We could have done this with one person. Good wine, by the way. Thank you.
So What's the difference between this conference center and what we had before?
Well, what happened is those rooms were kind of built during different years throughout the life here at Microsoft. I've been here for almost 10 years now, and when I came on board, there was only one large conference room, which was the old Cascade room, which this room replaced. And then a few years later, because of John Lazarus, we built some new rooms, a Kodiak room in Building 12 South, and then a few years later, we built another room, the Camino Orcas rooms. And so they were kind of spread out throughout a couple of different buildings, which are going to get torn down, which are right next door, and are going to be replaced by two new buildings, which are the last buildings they're going to build here on campus. There's just no more room. And so they had to move our conference rooms, and so we were able to consolidate them into this one facility right here.
So I suppose some people in our audience probably aren't quite into wine as much as you and I are, and some of them are probably drinking white Zinfandel and think that's pretty good, but want to move on to something better. What do you say to that?
Yeah, I know so many people that are in that same boat, and basically white Zinfandel, you leapfrog from Zinfandels, white Zinfandels to Chardonnays. And then from Chardonnays, you get to Pinot Noirs like this. And then from Pinot Noirs, you get to Merlots, then you get to Zinfandels, and then you get to Cabernets. And what I tell people is just drink what you like. I mean, that's basically all it is. And people's taste do change. I can't tell you how many friends I've got that were blush wine drinkers and are now Cabernet drinkers. And it's just a matter of developing your palate and just understanding the nuances of wine. Don't be intimidated by it, and just drink what you like.
Well, Bill, I enjoyed this chance to talk to you about the conference center and about wine and finding out a little bit more about your background and stuff. And since we've still got some wines in here, I think we'll just sit here and drink it.
Sounds good to me. Thanks for coming to the conference center, Robert.
Well, thanks for watching this episode. I hope you found it informative. Now, the next episode we have planned is on SQL Server. So pay attention to the website and watch for when it comes on. See you on the web.